The following demonstration will show how a virtual firewall functions to provide network security through packet filtering. HTTP port 80 and SSH port 22 traffic will be initially permitted from an external host through the firewall and then to a host located on an internal network. An IP tables filter will be applied to the firewall to deny all external to internal SSH traffic. Finally, a reverse SSH shell will be configured to show that SSH traffic can bypass a firewall even when explicitly denied. Each device is configured with Ubuntu 15.10 Linux. The external system has an IP address of 10.10.10.10/24. The internal system has an IP address of 192.168.100.5/24. The firewall has one external interface with an IP address of 10.10.10.9/24 and one internal interface with an IP address of 192.168.100/24. The internal network will simulate a corporate network. The external network will simulate the user's home network. The internal system is configured with local accounts named root and Bob. The external system is configured with a local account named Bob at Home. This is Bob's home system. The firewall has a local account named root. The internal system hosts an Apache web server configured at 192.168.100.5/index.html and is listening on TCP port 80 for network traffic. Linux firewall IP tables were utilized to provide the packet filtering capabilities for this demonstration. The following command was used on the firewall to provide our packet filtering. This command rejects all SSH traffic that originates on the firewall's external interface with a destination port of 22. Now let's take a look at the network connections on the internal and external systems. The output of this netstack command shows that we do not have any established connections on the internal system. However, we are listening on port 22 for SSH traffic. The output of this netstack command on the external system shows that we do not have any established connections. However, we are listening on port 22 for SSH traffic. The output of this netstack command on the internal system shows that we are listening on port 22 for SSH traffic. However, there aren't any established connections on this system. The output of this netstack command on the external system shows that we are listening on port 22 for SSH traffic, and there aren't any established connections on this system. From here, the user Bob at home will SSH into the internal network from the external network to show that SSH will work without any firewall rules enabled. Next, Bob will perform a whoami command to show that he is now Bob on the internal network versus Bob at home on the external network. Next, Bob will perform the hostname command to show that he is now connected to the internal host. We will terminate the SSH session. Next, Bob will connect to the internal web server to show that web traffic is flowing. Now we will look at the netstack command to show that we have a new connection while it's closing on port 80 from our external system to the internal web server. Next, we will implement the firewall rule that will block the SSH traffic from the external system to the internal system. First, we will verify that the IP tables are clear on the firewall. Then we will implement the firewall rule to block the traffic. We'll verify that the rule has been implemented, and it has. And then we will attempt to SSH from the external system to the internal system again. As you can see, the connection was refused. This is due to the firewall rule that we implemented in the last step. However, as I will demonstrate, web traffic is still flowing into and out of the internal network. This demonstrates how a firewall can be used to permit or deny network traffic based on the parameters that we define. However, there are ways to bypass firewalls. I will demonstrate one which is known as a reverse shell. So the user Bob wants to grant himself a connection from his external system to the internal network via SSH. But he now realizes that there is a firewall rule in place that is denying this type of activity. So what Bob will do is go to the internal system that he has an account on and create a reverse shell connection. Bob will execute the following command to create a reverse shell that he will use on his home system to grant himself access to the internal network, thereby bypassing the firewall. If we take a look at the netstat command, we will see that we have a new connection outbound established from our internal host to our external host. This connection is via SSH. Bob will complete this connection by logging into his home system and executing the following command. Notice that Bob used his corporate credentials to log into the network, even though he's on his at-home system. This network connection is an SSH tunnel. If we execute the hostname command, we are on the internal system, and the who am I command, and we'll see that we are Bob. If we go back to the internal system and execute a netstat command, we will now see that we have an established SSH connection coming from a random high port, and this is Bob's external system connecting to the internal network via SSH, even though it's denied in the firewall. So what we have done there is we have successfully circumvented the firewall rule that we put in place in an earlier step. The takeaway from this demonstration is that a rogue network admin like Bob can set up reverse shells to circumvent firewall rules that we put in place. As security professionals, we must monitor inbound and outbound traffic. And as we can see from this demonstration, an outbound firewall filter could mitigate this risk. Also, we must audit the activity of network administrators to ensure that they are staying within their lanes and doing what they're supposed to do. If it's possible, I recommend segmenting network administrator duties and implementing role-based access control. I also recommend placing a greater amount of emphasis on outbound traffic because this is the ultimate goal of any hacker or any rogue administrator. Thank you very much.